Hi, today we'll be replacing the FPC or touch connector on the iPad mini 3. So the first thing you're going to do is try and reflow the old joints. As you can see, I applied some flux, then some solder, and try to reflow all the connectors. We reflow the old solder so that you know it just kind of starts melting quicker than when it's actually in its original state. It's harder for it to melt than than our solder. I think it's the lead free solder, the one we apply. It is though, but the one which actually is already on the PCB most of the time is the leaded solder, which is harder to melt. I mean, the melting temperature is higher on that. So we're just gonna reflow all the joints, and then we'll heat it up, and we'll just take the connector off the PCB. I tend to apply some solder on the tip and then clean it because it basically takes off all the dirt off the solder tip, and the cleaner solder tip you have, the more easily the solder melts. Okay, we have applied the final shot of the solder flux. The next thing we're gonna do is heat up the whole FPC connector and take it right off the PCB. There we go. It has started to come off, and within seconds it'll completely come off. Here it is. Yep, it's off the board. So the next thing is cleaning the PCB. Once it's cleaned, we will apply some solder on all the pads, and then we're gonna place the FPC connector on onto the right position, and then just heat it up so that it just absorbs all the solder underneath. I found that is the actually easiest way of doing it, because the pins on the iPad mini 3 are very tiny, that any even the tiniest soldering iron is hard to get there. And I found the plastic material which is actually that connector is made of. It is quite a heat absorber. So as even though I was applying about 420 degrees Celsius heat on the PCB with the airflow average about 3. It didn't melt the plastic material in which was quite impressive. So there we go. We just apply some more flux on it and then just get our old way solder wick and just try and remove all the excessive solder on the wick. Make sure when you're removing the excess solder, put basically as much flux as you can, because it would make no it wouldn't actually damage your PCB, but it will help you removing all the flux, all the old solder. So I'm gonna apply some more flux. As I said, that as it wouldn't make any difference uh, whatever amount you use, because you can actually clean it off afterwards. As I previously mentioned in the videos, that the flux helps solder to flow. So when it obviously it's able to flow, it flows onto the wick and it stays there. And if you don't apply enough flux on the pads, the wick will actually joint onto the pad, and if you try and pull it, it actually can take the pad off the PCB. So make sure you apply as much flux as you can. And just in case if you see that the wick is really stuck on the PCB, try and check your temperature on the soldering iron. If you need to raise it raise it up, put flux on the wick and just keep it there as I'm keeping right now, even though my wick was not stuck to the solder pads. And in some cases you can apply some heat from the heat gun so that the solder melts and you can take the wick off. Make sure you don't actually pull it, because if you pull it, that means extra work. And I've actually I have shown a lot of cleaning, which is quite important for any of the connector changing. I mean, unless you've cleaned it 100%, that means uh, unless you've actually cleaned it 100%, your new joints may not be as good as you expect them to be. So from working even more, it's better if you just clean it in the first place. I may sound a bit awkward because it's about 2 a.m. when I'm actually recording this video for you guys. So sorry if I feel not as focused as I should be. Okay, when the cleaning process is done, now we will apply some solder onto the joints, because as I mentioned earlier on, that we're just gonna heat this connector in to the pad. So I've already applied some solder on the pads, but I've edited that part because it took me a bit longer than it was supposed to. So the next thing is just place the PCB connector on the PC on the I'm keep on saying PCB, it's PFC, sorry, it's FPC connector. So the next thing you're just gonna do is just apply some flux place the FPC connector on the board and heat it up, and it should settle down itself. If not, what you can do, you can place the FPC upside down and solder every single pin. Just apply a tiny bit of solder on every single pin so that it actually merges on the solder on the PCB easily. So I'm just applying I'm just putting the FPC on the PCB, and when you do that, just make sure that you place it on the right position, because once it's joined, then you really don't want to take it off and then rejoin it and take it off, rejoin it. So I'm just trying to adjust it on the PCB. Okay, I've got the heat gun with me, so I'm applying a little bit of heat as it will help for the soldering flux to flow. And now I'm just trying to heat it up. As I mentioned earlier, we are not jointing every single pin with the soldering iron, because it's nearly impossible to see through the eyes every single pin. I mean, the soldering iron tip does not reach the pins, so I've decided to heat it on the PCB. There we go. It's just if I had not applied enough soldering flux, it would not be moving as it is right now. I don't know if you guys can see it, but that is the best picture quality I can provide at this stage. I'm trying to get more stuff. I don't know, I'm just trying to get some sort of software which can let me record this camera and the camera on the microscope at the same time, so that you guys can actually see it more clearly. Okay, I can see that it's been placed properly. So the next thing is the inspection. We're just gonna check whether it is in place or it isn't. If it is not, then obviously you apply more heat, more flux, and try to bring it in the position. I'm just gonna try and move it through with the tweezer. Yeah, it's not moving. That means it's yeah, it's the joint was successful. And now a little bit of cleaning. Apply some circuit cleaner or alcohol, 99% alcohol, and brush the flux off. I usually use the ultrasonic cleaner, but that's a longer process, which I don't do while I'm recording. But usually I use the ultrasonic cleaner to actually clean it off. And it was such a small part of the board, and it was on the corner as well, so I did not really feel the need of putting it into the ultrasonic cleaner. So I'm just uh, visually checking it, all the joints and everything, checking all the pins. if they've been connected accordingly. That would actually take me a while. As I said, it's the pins are very small, and it had taken me a long time to actually check it. I think I had a doubt on few pins, so I'm checking them individually, but luckily they were okay. Okay, I think we're all done. So the next thing is testing the job we've done. So what I've done at this stage, I have not shown you the complete assembly of this motherboard, because it is very annoying, and I try and avoid it and ask my colleague to actually do it for me. But because I was recording, I did it myself. See, I was putting it wrong way first, and then I realized, okay, I had to put the charging port prior to the board. So I'm just gonna skip it. There we go, we are all done. I'm just placing the digitizer back on it, and I've switched it on. It's coming on. Okay, that means I have not damaged or done something to the board or the FPC of the LCD screen. So we'll just let it come on. It takes around 30 seconds to come on. We are almost there. Yep, there we go. It has come on. Okay, seems okay. So the next thing is going to be testing the touch. Yeah, the home button works fine. The touch is back. Okay, I don't know what else had I been doing with it. I think I didn't have the password for it. So what I'm gonna do, I'm just gonna skip the part where I was looking for the password. As soon as I get the password, I would record it again, and I'll show you that every single part of the digitizer worked perfectly fine. As I mentioned earlier on, I've got the password now, so I'm just gonna show you that it's working. It was actually the digitizer which was a bit faulty. It was not actually working from the very top corner, but the rest of the digi works fine. Yeah, that was a point where it wasn't working. Yeah, it would work sometimes, I mean, from some places. Yeah, but every single thing was working perfectly fine. I mean, I replaced the digitizer on it and it worked completely fine. Okay, that was it. Thank you for watching. If you liked the video, please hit like and share the video. Bye bye.